So in the previous session, we talked about Docker environment variables, right? Okay, so today we'll talk about Docker networks. Okay, so before understanding Docker networks, so let's take a simple, requirement where, so you have two microservices, microservice A and B. Okay, so one, you can take it as a to-do application written in Node.js or Python. And then there is this database, so which is MySQL, both running as containers. Okay. Now, how do you connect your front end or this to-do application with the database so that it can store the data? Hmm. So how do you configure the to-do app to connect to the database? So basically you will require an endpoint, right? For the database, right guys? So which means you need a URL. So URL in the sense it can be IP colon port, or it can be the DNS name colon port, right? And authentication, right? Correct. Yes, are you there?
Yes,
Yeah, yes.
Okay. So the to-do app requires the MySQL databases, the IP or the DNS name along with the port number. So database, MySQL always listens on 3306. That is pretty standard. And also in order to connect to the database, your to-do app also requires the credentials, right? The username and password. So the username and password, anyways, I'll set when I create this database. So the credentials can be easily provided to the to-do database. So how do you provide those credentials? Either I can pass them as environment
environment.
variables or through configuration files. There are multiple ways. Okay, but the thing is, how do you, connect to this MySQL database? So which URL you will give, or what IP address you will use, what DNS name you will use. Okay. So let's assume we use the IP address of the container. Okay, so container IP address of this MySQL. So let's assume this is IP2. Okay, so I'll configure my to-do app to use. So this HTTP, I'm just assuming this as the URL IP2 colon 3306 to connect to this database. Correct?
Correct.
Okay, so what will happen if this MySQL database, this information I provided to the, to-do application. Now, what will happen if MySQL database container fails, or if it restart due to some issue, and its IP address changes? Because IP addresses change, right? Whenever a container restarts. Okay, usually the IP address changes. Okay. Then what will happen to your to-do application? Will it be able to connect to the MySQL database using the old IP address? It is not possible, right? So in this case, what you have to do, you have to bring down to-do app, give it new information of the database container, and then bring it up again. Right. Okay. So that's the reason why we cannot go for IP addresses, because they are not, static in case of Docker containers. Okay. So how do you resolve this issue? Okay, so we will understand about that. Okay, so for that we need to understand the networking part of Docker, what all default networks we have, default networking drivers we have. Okay, so here container networking refers to the ability of containers, to talk to each other or communicate with each other inside your Docker host. Okay, and containers have networking enabled by default. Okay, so here, they can make outbound connections. So when you create a container, okay, like Nginx or Ubuntu, so by default, if you exec into the container and if you try to download anything, you'll be able to download it. Okay, so outbound connections are not blocked. But inbound connections, we already know, right? If someone has to access your application from outside, so we usually do port mapping, correct? So we assign a port on the host machine colon a port on your container, right? So this is how we open inbound connections to the container. Got it? Right, guys?
Yes.
Okay. And also here, when we talk about giving networking to a container, so that networking is also, isolated from other containers, which means a container will not have any information about other containers, like what networking the other containers use. Okay, whether they are containers or a simple EC2 instance, even that also they won't understand. Okay, it is completely isolated, and every container gets its own networking interface. Okay, with its own IP address, own gateway, own routing table, own DNS services. Okay, so just like a container gets its own set of file system, I mean, we talked about namespaces, right? So we have networking namespaces, file system, process namespace. So which means every container gets its own networking. Okay. But before understanding what network, options we have, what networking your container uses, let's talk about few basic concepts in networking. So in networking, we have bridge networks, right? So what is a bridge network? It basically separates two different networks, correct? So if I have, a network, so which belong to this CIDR, and if I have other network belong to this CIDR. So in order to connect these two different networks, okay, so basically we'll have a bridge. Okay. So what will happen if, let's say, if I say this host is this, and the other host is this. So if this host tries to ping 10.0.0.2, so it won't cross the bridge because it belong to the same network. Okay, but if this host try to ping this particular IP address, then it should cross the bridge, okay, to talk to the other network, right?
Right.
Okay. And also, what is the meaning of this /8?
Uh, Class A.
No, let's assume this is CIDR, classless inter-domain routing. So there are no classes. I can assign anything.
Okay.
What is
It
/8?
8 bit circle mask in the
Subnetting.
subnet.
Okay. So which means, let's say, if this is IPv4, we know that each octet can be represented by 8 bits, right? So overall, there will be 32 bits for an IPv4 address. Okay, then what is /8 or /16/22? Okay,
8 bits
so
are
here,
Network bits. Network
8 bits
bits.
net,
are masked in the
okay,
subnet
so
Network.
8 bits are
mask.
Network
network. Okay, so which means first 8 bits are assigned to a network. The other 24 bits are assigned for the
host.
host devices. So which means there can be 2 power 24
24 host.
devices, in the subnet. Okay. So usually we also subtract 2 for our first IP address and our last IP address. Okay, so the last IP address is always used for broadcast and the first IP address is always used for the device, right? Okay. So this is a bridge network. Okay. So basically bridge network works on layer 2 protocol. It is not layer 3. So layer 2 protocol means it works on data link layer. It purely works on the Ethernet addresses or the MAC addresses. Okay. Right. So whenever it receives any information of the outbound traffic, it is going to extract the MAC address of the destination, and then it will figure out whether this MAC address belong to the other network or it is in the same network. Only if the MAC address belong to the other network, your bridge is going to forward the traffic to the other network. Okay. So now in Linux, you have a tool called BRCTCL, okay, bridge cuddle tool. So using this, you can basically see all the bridge networks available, create bridges. Okay, so I'm going to show this utility. Okay, it won't work on Windows, so let's start our EC2 instance and work with the networks. Okay, now by default Docker uses software bridge because you cannot have any hardware bridge in order to connect containers. Okay, so Docker uses the same technique of bridge. Okay, so here what will happen is it uses software bridge and all the containers are connected to this bridge network. Okay, and so here, so by default, you know, Docker will restrict communication across bridge networks, which means, so if I have a container, let's say I have 5 containers, so I'm just taking this as bridge network one. There are, 3 containers here. So when I connect all these 3 containers to the bridge network B1, so they all can communicate with each other. But if there is any bridge B2, so where I have C4 container connected, so there won't be any communication between C1 and C4. Okay, it is completely blocked. Okay, so this makes bridge networks ideal for hosting multiple applications on the same Docker network. Okay, so whenever I want to, deploy 3 containers, okay, separate applications, okay, of let's say separate containers for microservices. Let's assume there is an application that needs 3 microservices. So I have 3 containers. What I can do is I can create a separate network for them, and then I can have all these 3 containers connected to the same B5 bridge network. So they can internally talk to each other, but all the other containers belonging to other networks cannot talk to them. Okay.
So again, subnet mask is not will not help here.
So here all those things will not work.
Okay.
Okay. So they are completely isolated. In case if any container wants to talk to the other container, both should belong to the same bridge network.
Yeah. Okay.
Okay. And here you also have other networks. Okay. So when you have multiple Docker machines, okay, probably you can take the case of Docker Swarm where we have multiple Docker hosts. So in that case, so we have other type of network known as overlay network. So that spans across multiple hosts inside your Docker Swarm cluster. Okay, so we will talk about that later. Okay, and here when you install Docker, right, a default bridge network called Docker 0. It is not Docker O. It is Docker 0. So a default bridge network is automatically created. Okay, and all the containers connect to that network by default. That's the reason why you will be able to ping other containers, because all the containers by default they connect to the same bridge network. Of course you can also create your own bridge network and then attach containers to it so that other containers cannot talk to these containers. So you can also create such isolation. Okay, so this is a basic diagram to understand container networking. Okay, how each container gets its IP address and how the communication flows. Okay, so here these are all containers, and then you can just take this as your host part. So here, so whenever you install Docker, right, a default bridge network called Docker 0 is created. Okay, since this is a bridge network, so this should have a CIDR range, right? Like what all IP addresses it can allocate to all the devices that connect to this bridge network. Okay, so it has the CIDR of 172.17.0.0/16. So which means any container that is connected to this bridge network gets an IP address in the range 172.17.0.2, like 0.2, 0.3, all the way till 255.254. Okay, clear, guys?
Clear.
Okay. And if I create other bridge network, okay, another bridge network, then that bridge network, custom bridge network will get the CIDR 170.18, other will get 170.19. And of course, you can also configure this. or let Docker decide the range, the range by itself. Okay, you can do that as well. Okay. Now the thing is how each container gets, its own IP address. Okay. So if you look at this, image, so here each container is getting its own ETH0. Okay. Right. So this is the interface. You can just take it as Ethernet interface. Okay. Each container getting its own interface with the same name because of network namespaces. Okay. But how does this container actually makes an outbound connection is, if you see whenever a container is created, okay, it gets connected to the Docker 0, that's the default bridge network. And also there is a virtual Ethernet pair that is created. So we call it as VTH star. The star will be a name, so that will be auto assigned. Okay, so this is a virtual Ethernet connection. So where it is connecting the container to your Docker 0 network. You can see here whenever I create a container, a separate virtual Ethernet connection is established that is connecting your container to your Docker 0 network. Thus, each container gets, the IP address. So from the IP pool of this Docker 0 network. Got it? Clear, guys?
Can you repeat again, please?
Okay. So here, each container should get its own IP address, right?
Right.
From the Docker 0.
Yes.
Okay, so Docker 0, how this container is going to get created is because see, these are all softwares, right? So there is no direct cable that I can attach it to my system and then attach it to the container, right? So it's
Right.
all virtual. So that's the reason why we have virtual Ethernet connections. Okay, so this VTH, you can just take this as just a configuration. It's a file. So what this is actually doing is it is connecting one end of the container to the Docker 0. Okay. So that is basic understanding. You don't require to understand, much. Okay. But there is this, website called labs.ximios.com. Okay. If you go to this tutorial where they explain about container networking from scratch, you'll get more information of how to manually create network namespaces, how to create a container, how to attach it to, the Docker 0. Okay, so there are some manual steps which are not required. So I just mentioned this link so that if you are interested, you can just go and understand, but it is really not required. Okay, it is not at all required. If you still want to, just understand, you can just go and visit this site. Okay,
Where is the link, Vikram?
here in the presentation. It will be in the text document I shared.
Okay. Okay. Thank you.
Okay. So the same image. Okay. So here, if you just take this as your Linux server, so that Linux server will have its own physical ETH0 and local, loopback address. So this is a root network namespace. Okay. And every container that is created itself will have its own network namespace. So we call it, we are calling it network namespace 0, network namespace 1. Okay. So every container will have its local loopback, right? That's common, right? Loopback addresses are common. And now every container should have its own ETH0, okay, Ethernet connections. So that should be connected to the default bridge network that is Docker 0. So it is possible through virtual Ethernet connections like this. So which connects one end of the, connection to the container, the other end to the Docker 0 bridge network. It's not Docker 0 bridge network. If you create any custom bridge network, so the same concept applies. Okay. But so this BR0 or Docker 0, that's a default bridge network. Okay, so I'm going to show, so don't worry. Okay, and also, see, every container here is getting its own private IP address, right? Right. So by
Right.
default, if you see all the containers are connected to the same Docker 0 network. Okay, So which makes it's possible to actually talk to each other. Okay. So how they talk to each other, like which IP they use, or is there any other method? So we are going to talk. That's really important. And also one more thing here, let's say there is this website that I wanted to access, let's say something like google.com. Okay. So how can a container can talk to this google.com site or any external site from a private IP address? It is not possible, right? If you want to talk to google.com, you should definitely have a public IP address. Correct.
Yeah.
Okay. So here, in fact, Docker also uses the concept of NAT. So NAT means you basically convert a private IP address into public IP address. Okay. So in order to access the external site. Okay. So, your outbound connections from your containers, when they leave, they don't leave with the private IP addresses. They'll just leave your host machine, just like other packets leave your host machine. Okay, they're going to use the public IP address that is assigned to your system. Okay, go to the internet, fetch the data, and then the data again goes back to the container. Okay, so containers also use this NAT technique so that they can make outbound connections. So you don't have to worry about this. So all these are handled internally only. Okay, so now if I run brctcl show, okay, you can see I have a default bridge network, right? Docker 0, correct?
Yes.
And also if I do if config, you'll also see Docker 0. Okay, and then this is your broadcast. This is your Ethernet. This is your subnet mask, which indicates, the network belong to, 172.17.0.0/16. Okay, so this is your for the, for the router, and then this is for the, broadcast. Okay. So that is, use of brctcl. You can see all the bridge networks that gets created. Okay. So now when you install Docker, it creates three different types of networks called bridge, none, and host. Okay. So these are the names of the network. Okay. And you also have default bridge network called Docker 0. Okay. So here it creates a little bit of confusion. Okay. Because these are actually drivers. Okay, so you have bridge driver, none driver, and host driver. And the default bridge network that we have is Docker 0. Okay, if you create any custom bridge network, it is just going to use the bridge driver to create that custom bridge network for you. Okay, so how do I see all the default networks is? I can simply run Docker network and see what all various options I have. You have ls to see all the networks, create to create a network, rm to remove a network, prune to remove all the networks, and if a container is already there, okay, and if you want to connect a container to an existing network, you use connect. If you want to disconnect a container from a network, you use disconnect. Okay, so here we don't use connect and disconnect while creating a container. So when the container is already there, if you want to connect or disconnect from a network, we will do. Okay, so let me get all the list of networks. Okay, so if you see, we have three different networks called bridge, host, and null, using the driver called bridge, host, and null. Okay, so these are the drivers, and these are the default networks. Okay, right? Okay, if you do Docker network ls, you're going to see this information. Okay, and of course, you can also inspect a network. Okay, so how do you inspect a network? Let's say Docker network inspect. I'm going to inspect the name of the network called bridge. So don't use the driver name, use the network name called bridge. Okay, so this is the default bridge network. Okay, so the name itself is bridge. Okay, IPv6 is not enabled, and this has a subnet of 172.17.0.0/16. So any container that gets connected to this bridge network gets the IP within this range. Okay, and some options. Okay, but this is the only thing that is important for us. Okay.
What is the meaning of a driver here?
So meaning of a driver means it is just like a software that is actually creating all these configurations on your Docker host. Okay, so what is an audio driver in your system? It is actually installing some kind of packages, patches, some softwares that talk to your device kernel to enable sound, right?
Yeah.
Okay, like driver for your graphic card, driver for your sound card, driver for your LAN, Wi-Fi. So they are actually installing some applications to talk to your kernel to enable all those features. So when we talk about driver, so what driver here is doing is it is configuring your networking. Like when I talk about bridge network, so what this is going to do, this is going to insert some networking rules into the container, right? But when I talk about non-network, so it is a driver that actually disables the networking. Okay,
Okay, but
got it.
so is it always like a one-to-one mapping? You have one network, bridge network, and there is one, I mean, there is a corresponding driver for it,
No,
or
no,
it
no.
can be
No,
many,
it's
and
not
there is
like
a
that. See, if I have a Bluetooth driver,
uh,
okay, but here these drivers can be generic driver, which means any Bluetooth. I mean, if your laptop has a Bluetooth device from any manufacturer, a generic Bluetooth driver can work. Okay, but if the
okay,
manufacturer is providing their own driver for their own hardware, which enhances the experience even more. So that is a driver that works only for that, the Bluetooth hardware manufactured by that manufacturer. Okay. So here drivers are generic. Okay.
okay,
When I say driver, so whenever a container gets created, a bridge driver is invoked and all the networking rules are implemented for that container.
okay,
Okay. It is not one-to-one mapping.
okay.
It is a piece of software.
Oh,
Okay,
okay,
so you have to explicitly say that a container should use this driver, to create its networking.
okay,
Okay. So all these drivers are enabled by default. Okay, so you have bridge driver, host driver, none driver. Okay, so I'll explain the differences later. And here you also have an overlay driver. But if you see Docker Network LS, you won't see this driver, because on a single Docker host, this overlay driver is of not this driver is not required. This driver is only required if you have multiple Docker hosts, just like in your Docker Swarm setup. Okay, so when you enable Docker Swarm, so then this overlay driver gets installed in your host machine, or you can say it gets enabled. Okay,
okay. So
now
this
let's
network,
mm,
so these are all typically network types, right? If the different
network
network
types.
types of, yeah, so
Yes,
that is the
provided
same as
by
the network.
various drivers.
Yes.
Okay. So
Oh,
if you need inter-host communication, which means Docker host to Docker host communication. So how that communication is going to be established? So it is going to be it is going to be taken care by this overlay driver. Okay, let's say in Kubernetes you have various container networking interfaces like VNet, Flannel, Calico. So what these are doing here? These are actually implementing networking across your complete Kubernetes cluster. Okay.
okay,
Okay, so now, as we already said, we have by default three network drivers: bridge, none, and host. Okay, so we need to understand the difference. So there are other types of drivers as well, but we don't use them. So one is IP-VLAN, so which will enable IPv6 networking and addressing. And then we have MAC VLAN. So this makes it possible to assign a MAC address to a container and establish the communication using the MAC addresses. So these are not at all used. Okay, I've never used them in my whole career, so you don't have to worry. So if anyone asks you about various network drivers, you can simply say bridge, host, and none. There is overlay for the Docker Swarm. You can just mention IP VLAN and MAC VLAN, but we don't actually use. Okay. Now let's talk about bridge network because this is really important. Okay. So there are some disadvantages of using the default bridge network, that is Docker 0. Okay. So I'll explain what is that disadvantage. You know. So first, let's try to create a container. I'm just creating a container by the name web. I'll just spin up this Nginx container. Okay, let's first understand which IP address gets assigned to this container, to which network it is basically attached to. Okay, in order to get information about the container, so I would do Docker container inspect. The name of the container that I gave is web. Okay, if you look at the networking part, okay, so this is getting an IP address of 0.2, so which is in the CIDR range of default bridge network, that is 172.17.0.0. Okay, so it is connected to the default bridge network. Okay, and you can also verify it by inspecting the default bridge network, that is bridge. Okay, if you inspect the bridge, you will find extra information, from previous output. That is, inside the containers, you will see the name of the container web with its own IP address. Okay, is now connected to this bridge network. Okay, so if I create one more container called web2. Okay, so here, if you see, I'm not mentioning any kind of network to use because it will by default use the default bridge. Now, if you inspect the bridge network, you will see two different containers are attached to it. So one is with 0.2 and one is with 0.3. Okay, you can also see the container names. Clear, guys? Okay, so
Yeah.
let me remove both web and web 1. Sorry, web 2, I think. Okay.
Vikram, by default, they can ping each other, right?
Yeah, so by default they can ping each other. I'm coming to that only. Okay. So let me run a container called C1. Okay. I'll just use Nginx Alpine because this has ping utility. Remember, this has a ping utility. Your normal Nginx latest will not have. So I'll create one more called C2. Okay, and so there are C1 and C2 all connected to the default network. Okay. I'll log in into C1, Docker exec -it, C1. I can start the bash process and then enter it and then use ping, the container. Okay. But before that, let me inspect the bridge network because that is required. I'll tell you why it is required. Remember, C1 has 0.2 and C2 has 0.3. Okay. Now let's do Docker exec -it. Log in into C1, start the bash process. Bash is not there. Let's start sh. Okay, sh is there. Now try to ping a C2. Here I'm trying to use the name of the container, which is C2. Is it working?
No.
No. Okay. So I have to use 0.3 so I can reach it. Okay. So which means a resolution through the container names. I mean, DNS resolution through container names is not possible in the default bridge network. This is what I wanted to show you guys. Okay. And of course, you will have all sort of files inside each container. Okay. This is etc host. If you see, your container ID is also added as a DNS entry inside these etc host. Okay, and also you have etc resolve conf file. Okay, etc resolve conf file. So we all know that this is also a configuration file that gets added. Okay. This is one more file that I wanted to show you. Okay, I'll come back to this file again. And yeah, so if you take the case of C2 as well. Okay, so if I just exec into C2 and try to ping C1, it won't work. But if I just use the IP address of C1, it will work. Okay, so DNS resolution is not possible. Now going back to our previous issue here. Okay, so when I have C1 and C2, if I try to connect to C2 with the name of the C2, it is not possible. So which is a challenging thing for me, because in case if MySQL container goes down and comes up, it container IP address might change. Then, this to-do app has to be redeployed, giving it the information about the C2's new IP address. Okay, so this is one biggest drawback of using the default bridge network. There is no DNS resolution using the names. Okay, so which means if I just open my Google Chrome browser and if I just type www.google.com, it won't respond. But if I use the IP address of your Google server, it will respond. But I can't remember the IP addresses all the time, right? I should rely only on the names. Okay, but that is not possible with your default bridge network, that is Docker 0. Okay, so we know what is DNS. So if you want to know more about DNS, how DNS resolution work, okay, so you have to definitely check out these two sites. Again, these are part of the text document that we are sharing. Okay, so if you want to know how the request flows, so what will happen if you just enter www.google.com, so where your browser looks for the IP address which is mapped to this domain. Okay, so what it will do if it won't find in your local cache where the request gets forwarded. Okay, so that entire thing is explained in the DNS. Okay, and also if you just see the domain naming hierarchy. Okay, so we have top level domains, that is .com, .in, .edu. Okay, all these things. Okay, and then we have second level domain, let's say google.com. So Google becomes the second level domain and com becomes the top level domain. And coming to the subdomain, if I say support.computerhope.com, so the .com is top level domain, computer hope is second level domain, and support is basically your subdomain. Okay, okay, if subdomain is not available, you can assume it to be www. Okay, okay, as we already said, so if you look at the DNS resolution in the default bridge network, it is not possible. That's the reason why we go for custom bridge networks. Okay, but can we also enable this DNS resolution, somehow in the default bridge network as well? Yes, it is there. Okay, but it requires you to use something known as hyphen link. Okay, so hyphen link, if you uh, just search for the official documentation. Okay, if you go to this legacy container links, so if you see here, you cannot, I mean, you can use this option, but you should use it with caution, because Docker might remove this option anytime in the coming releases, or they may retain this as a legacy option, but you should not use this. Okay, so how to use this is, let me just show you. Okay, so here first, let me remove both C1 and C2. Okay, so now I'm creating a container first. Okay, I'll call it as probably DB. Okay, just for our understanding, I'm calling this as DB. Okay, and remember DB is our second container. Okay, now I'll create one more container called to do. So this is like my front end. So front end wants to talk to the database, but database, container is named DB. So when I try to use ping DB from my to-do container, it fails. Okay, so that's the reason why I'm going for DB's containers IP address. Now I'm trying to resolve that issue. So how do I resolve it? When I create this to-do container, I will link it with the DB container. Okay, got it? Okay, so
So
which means this to-do container can now talk to this DB container with the DB as the DNS name. Okay, and also there is this alias, not alias. I think, yeah, I think it is alias. That's a secondary name. So let me just see how we give that, or which one is alias. I just forgot. I think it's given in the presentation. Just a second, guys. Uh, I mean, I should use DB colon DB, but I forgot which one is alias and which one is. Just give me a moment. Hyphen links. Oh, so here also I just use the same names. Okay, let me figure out which one is. Okay, here also they used hyphen link. Here. Okay, hyphen link name or ID and alias, which means so here so I wanted to link to the DB container. Okay, so if you put DB colon DB, so it is like you can talk to DB container with the DB as the DNS name, or else let's say I can also give it as one more name called database, which means this to-do can talk to this DB with both DB as the DNS name or database as the DNS name. Okay, see, I created a link. Now it's time to test it. So I'll do docker exec -it. Okay, so the name of the container is to-do, and then let me start the sh. So now if I try to ping the DB container with the DB as the name, see it is working. Okay, and now if I try to use a database as the name, see it is still working, right? And of course I can use the database containers IP address, that is this address, to ping. That will also work. Now what is the advantage of this is, in case if this container goes down, okay, I will create the container with the same DB as the name, right? Which means the to-do application need not to be deployed every time this DB container is redeployed, right? Because I'm redeploying this DB with the same name. Got it, guys?
got it. Uh, so
Okay.
this link flag won't work from DB side to do link.
Yeah, so I'll also show that. And if you look at the host file, okay, so this is where actually the trick is happening. So what exactly happening inside this to-do when you link it with the DB container is, actually inside the to-do, there are these DNS entries that are getting added. Okay, so what it is adding, what your Docker is adding is, so in case if I just say connect to DB, or if I just say connect to database, it is actually internally converting into this IP address. Okay, correct.
Correct.
So there is no, a separate DNS server, which is actually mapping all those things. So here it is actually doing this linking. Okay, so this is legacy and this is not at all recommended. Okay, so similarly, if I try to use, if I log into DB container and if I try to just check the host file, okay, so here you don't have that entry because you just created link only in the to-do. If I ping that to-do container from my DB, it won't work. Okay, so this is another challenge. Okay, now what we'll do is let's remove both to do and DB containers. Okay, so that is the a disadvantage. There is no DNS resolution. Okay, so this is just one of the image that is explaining your containers. Okay, and the default bridge network. Okay, but what about custom bridge network? Okay, can I create a custom bridge network? Yes. So using Docker network create and giving it any name, I can create a custom bridge network. So I'll just say Docker network create. The name of the custom network is mynet. Okay, so you just create a network, but still your containers won't connect to this network unless you explicitly mention that a container should connect to this network. Otherwise, by default, they'll go to Docker 0 only. Okay, so once you create a network, it is uh, best to inspect it. Okay, in order to see what is its subnet. Okay, if you see the subnet is 172.18, okay, which is different from the previous default network that is 172.17. Okay,
Suppose if we
clear?
lost the DB, right, earlier DB,
Hmm.
so the IP will get changed again, right?
Hmm.
So in that case, the to-do app won't be able to find
Won't be
the
able to connect. It will only be able to connect if it comes with the same
same
IP
IP, right?
address again. Okay, that's the reason why this hyphen link should not be used at all.
Okay.
Okay, and this is the the new subnet 170.18. Okay, so now I can create containers. Okay, so if you just see Docker container run help section. Okay, so somewhere you'll find hyphen network. Hyphen network. Okay, so I can connect a container to a network using hyphen network, or I think hyphen net should also work, but let's go for the. Okay, so now we'll create the same. So this time I don't have to create DB first or something like that. Okay, I'm creating to do only. But this time I'll connect this particular container, to the network called mynet. Okay. Of course, you can connect a container to multiple networks by passing hyphen network multiple times. Okay, so one container with the name to do is created. Another container, I'm calling it as TB, and just connect it to the same mynet. And then if you inspect mynet, you will see that two containers called todo and db. Okay, so one with 0.2 and the other with 0.3 connected to the same connected to this newly created bridge network. Okay, in fact, you can also do Docker network ls to see that a bridge network is created. Oh, sorry, here mynet. So this mynet is a name and it is using the driver bridge. And we should also see this brctcl. Okay, so when this brctcl will show these virtual Ethernet, interfaces is, so whenever you create a container, it creates a virtual Ethernet interface. Okay, since we have two containers now, so you have these two VTHs. Okay, yeah. So now, what should we test is we should test the connectivity. So let's exec into to-do container and start the sh process. Okay, so let's ping deep. Okay, working.
Yeah.
Okay, so let me check the etc host entry. Okay, if you see there is no manual entry, there is no hard entry that says if someone says db, just point to that IP address. Okay, that is not there. But the interesting thing that you'll find in this resolve.conf file, there is a name server or a DNS server okay, which is actually running at 127.0.0.11. Okay.
So internally it is mapping, right?
Yeah. So there is this name server which is running on this IP address internally. So that is having the mapping of your container name and the IP address. Okay. So here it is, we are not at all hard coding. In case if DB container or any container gets restarted, okay, if it restarts with a different IP address, the name server, the DNS entries in the name server gets automatically updated. Okay. So no container will get impacted. Got it?
Yes.
Okay, so the same is the case with the DB container. So if you just exec into the DB container, okay, and then just ping your to-do container, it is going to work as expected. So for this reason only, we should actually go for custom bridge network. And if you are using Docker Compose, to deploy multiple containers at once, let's say 10 different containers, you don't have to worry about creating a custom bridge network and deploy all those 10 containers, because Docker Compose by default, when it tries to deploy all those 10 containers, it itself creates a custom bridge network and puts all the containers inside it. Okay, clear?
And can we see the DNS entries for that IP address?
No, actually you can try. I never tried to access this IP address and all, but of course you can try. Okay. And there is one more thing here. So now what I'm doing is I'll create one more network called, let's say, security. Okay.
And and CIDR will be same for all the networks in the Docker.
Now, one more thing. So here I did not show about these commands. So whenever you create another network, okay, like Docker network create, and you give the name of the network, right? So by default, it chooses the bridge driver. Okay, so you don't have to pass this flag. But when you're trying to create a driver, you also have an option to select the subnet. Okay, and you also have an option to give the gateway information. Okay, in case if you
Okay.
have a strict IP address, to be used, you can pass it. Okay. Now what I did is I created a network called security. Okay, and then I'm going to deploy a container by the name, let's say, uh, I'm just calling it as a firewall, and then I'll connect to this security network. Okay, so it is not a proper example. I'm not using proper names and all. It makes no sense calling it as firewall and all. Okay, but there is this security network inside it. A firewall is deployed. Okay, now let's exec into one of our container. It can be DB or it can be to-do, because both belong to the same network. So I'm just connecting to one of those containers and trying to ping this security container. Okay, so the security container is known as firewall, right? Okay. And if I try to, okay, so let me also inspect this security network to find the IP address. You can see this is the IP address of my firewall container. So let me, from my DB machine, try to ping the IP address. Okay. See, it is not reachable. So with both container name and IP address, your containers in one network cannot reach the containers in the other network. It can be with the DNS name. It can be with the uh,
Hello.
Hello? Yeah, sorry. Okay. So you can't reach it, both with the DNS name as well as the IP address. Okay. So what should we do now?
Gateway.
Okay. So here we have something known as MyNet. Okay. So we have something known as security, right? So we have to-do container here, DB container here. You have firewall container here, right? So now if I try to establish the communication, it is not possible. Okay. So what I can do to establish the communication is either you uh, connect firewall container to this my network. Okay. So already it has security network connected to my network. So now this firewall container will be part of both mynet and security. So it will also have two IP addresses, one coming from the securities cider and the other coming from my mynet cider. So now firewall container is attached to both mynet and security. So now this firewall is also part of this mynet. Okay. So you can talk to each other. Okay. So that is one. Otherwise, what you can do is you can create another network called X, and to this network, connect both your firewall and to. Okay. So that they can talk in that network. Okay. Got it, guys? Okay, so since I cannot start a container with other networks, so I can dynamically attach a container or detach a container from a network. Okay, so how do I do it? Say your firewall container is part of security, right? Now what I'll do is I'll say Docker network attach. Okay, attach, or I think it is connect. Okay, so what I'm doing is I'm using Docker network attach. I'm attaching my net to the firewall container. Okay, clear?
Okay. Regardless of the network thing, different networks thing, right?
So I'm just taking a network and then attaching a container name, a container.
From a different network.
From it can be any network. Okay. If you look at the container now if I do Docker container inspect and the name of the container is firewall, you will see two IP addresses. Okay, so one coming from my net
Okay.
and the other coming from the security network. Okay. Now, your to-do, your DB and security, all are in a same network. So if I exec into DB container, and if I try to ping this container known as firewall, it should be able to resolve. Okay. And let's say I don't want this, firewall container to be in mynet again. Okay. So since I connected, just disconnect. Okay. If I try to do ping again, it won't work again. Got it? So that is the advantage of using Docker Network Connect and the disconnect. Okay. So that is the custom bridge network. Okay. Also known as user defined network. Okay. So it is only possible because, we have a DNS server which is running on 127.0.0.11. Okay. And this DNS server's IP address is inserted into each container into etc resolve conf file. So that's the reason why you are able to ping other containers with their names as the DNS name. Okay. So this clearly shows inside the DNS server, you'll have the mapping between the container name and the IP address. So whenever a container restarts, okay, if IP address changes, it gets automatically updated in the embedded DNS server running on that 0.11 IP. Clear, guys? So no need to use hyphen link and all. Okay, now coming to the port mapping. Okay, so this concept is we already seen this concept. Okay, so by default all the containers will be isolated, but they'll have the onboard connection, but inbound connection is not possible unless you use -p to open the port. Okay, so here I'm running Nginx and MySQL. Okay, Nginx, which is running on 5000 port, is exposed on 80. Similarly, one more container, Nginx, running on same 5000 port, it is exposed on 8000. One is exposed on 8001. MySQL, which runs on 3306, it is exposed on the same port on host. Another MySQL is exposed on a different port. But if you try to use the port which is already occupied, you are going to get an error. Okay, right, guys?
Right.
Okay, now what about host network? Okay, so this host network is a special network where a container directly gets attached to the host network. Okay, it won't have any IP address of its own. It will have the IP address of the host machine itself. Okay, and there is no port mapping required because it directly connects to the host machine on a on a specific port. Okay, which means if Nginx container which listens on 80 is on a host network, you cannot create another container on the host network. Okay, port mapping is not supported. Okay, so for example, let me remove all the containers. Okay, so let me just run C1. Let me run Nginx. Okay, so here I'm not using any port mapping because whatever port your container listens on, it gets directly attached to the host. So here I'm just saying hyphen network is nothing but your host network. Okay, so I created it. Now if I try to inspect this C1 container, you will see that the IP addresses and all are null. Okay, because it gets the IP address of the same host machine. And if I try to create another container called C2 from the same Nginx image using the same host network, okay, it will appear to be successful, but if you do docker ps-a, then you'll understand that the container failed. The reason why container failed is because already there is a container Nginx running on 80. You cannot have another container running on the same 80 again. Got it? So that is directly connecting a container to the network. Okay. And then we have the last one, which is none network. So none networking means we completely disable, networking. Okay. All I have to do is, just use network as none. Okay. And if I try to, let's say, container inspect of C1, okay, you can see that it is none. So completely the networking is disabled to this. Okay. You can do docker exec -it and C1 bash. Okay. So this is the only way you can connect.
In which scenario we will use non-network?
In case if you want to disable networking, like you don't want this container to be available to anyone. Okay. There are some containers which doesn't require any networking. Like you want to run a container to do a job that doesn't require any internet access. Okay. So there you will disable it. I mean, I never use none network. But it is there in order to disable, networking. Okay. And coming to the last network type, which is overlay network. Okay, so this network makes multiple Docker host machines talk to each other. Okay, so this is used in Docker Swarm, where you'll have multiple Docker hosts as part of a Swarm cluster. There you'll have a overlay network that spans across your complete Docker Swarm cluster.